Today we're going to start off by looking at the calculator to examine what's going on with what's called a midsegment of a triangle. Now, a midsegment will be a segment that joins the midpoints of two sides of a triangle. So the first thing we are going to do is we are going to construct a midpoint. So I'm going to pick any two sides. I'm going to take side AB, and I'm going to take side BC, and what I'm going to do at this point is I am going to create a segment by connecting these 2 points. So what we have just created is a midsegment of this triangle. And two important properties that we are going to notice. One is going to be their length. And if I measure this length, and I measure the opposite side's length, and I compare, I can even move the triangle around to get a better idea. That might be really visible. I can see the midsegment is about half the length of the third side. Another thing that we can do is compare their slopes. So if I were to measure the slope of this segment, put it off to this side, and in order to measure this one, I will actually have to construct another segment. And now I'll go back and I can measure this segment. And I think, again, that should be pretty obvious what we're seeing going on with the segments. No matter what happens, even if I were to pick a different point, I could see that looks like they're going to be half the length, and it also looks like they will be parallel. So as we're moving through with our midsegments, we want to keep those two important properties in our mind. So on our note sheet here, it says if a triangle's midsegment, if a segment joins the midpoints of two sides of a triangle, then we can say the segment is parallel, I'm going to use my symbol, to the third side, meaning the side that we did not create a midpoint on. And we are going to say the segment is half the length of the third side. Okay, so using those two important properties, keeping that in mind, we're going to answer a few questions below. So I can look at this triangle, a couple of things to kind of keep in mind. I'm noticing that these marks here, like the mark on CE and the mark on EB, that's telling me that those two segments are congruent, which ensures that E is a midpoint of CB. And I can see on the other side the same idea with these two segments being congruent. And again, so D is a midpoint. So right away that's telling me, since I'm connecting two midpoints, DE is a midsegment. So that means it is half the length of AC. So I could say DE is half of AC. I can also say DE is parallel to AC. So knowing that it's parallel, and they have told us that angle ACB is 74, they want us to find the measure of angle DEB. Well, if these two lines are parallel, this looks like here's a transversal. That's going to make these two angles corresponding angles. So I should know the measure of angle DEB is 74 degrees, since corresponding angles are congruent. Another example, and again, we're going to take, this one doesn't have as much marked, but we're going to take this picture and assume point R and point S to be midpoints of segments WX and WY respectively. Therefore, if those are the midpoints, I know that RS is a midsegment. And what that's going to do is then tell us it's half the length of the third side. So what that means is if RS is 9, XY, well, it's got to be double, so that's 18. It's also going to tell me that if S is the midpoint, and I see this bottom segment is 16 for SY, well, that means this top segment for WS is also 16. Taking another look, if I see again these lines mid-segment, I know that they're parallel. So kind of like what we did up above, if this is 70, this angle here is 70 because those are corresponding angles. So I'm going to take a look at triangle WRS, and I'm going to notice that we have 2 out of the 3 angles. We're just missing the bottom right-hand angle. And I know triangles have 180 degrees. So removing the 40, removing the 70, that's going to leave me with a total of 70 degrees. So this angle is also 70 degrees. Now again, parallel lines, taking a look at that angle that we just found and this angle Y on the bottom, I can tell you that must also be 70 because those are corresponding angles and they are congruent. Now, taking a look at our big triangle, I can see that this triangle must be isosceles since my 2 base angles are both 70 degrees. And if it's isosceles, well then I know that the 2 sides are going to be equal. Not only are the 2 sides equal, but keep in mind R is a midpoint, so that means their parts are also equal. So we've just found all of the missing angles and sides for that triangle. Another problem that we can take a look at is down here. So we're finding the perimeter, perimeter being the measurement of the outside, all of the lengths of the outside sides. So we're going to take a look and notice again the marking. So I see one marking here for 9, meaning this must be the same length, so that's also 9, which tells me this must be a midpoint. And I can do the same on the other side with side FG. I can see it's split and it looks like into 2 equal parts. So if this bottom part's 8, that means this other side is 8, which proves that this line that's labeled 14 must be a mid-segment because it's connecting midpoints. So if that's the case, I know that not only is this parallel to EG, but I also know it's going to be half the length of EG. So that means EG must be double or 28. So if I'm going to find the perimeter, I want to add up all of the outside sides. So this whole entire side I know is 18. This whole side I know is 16. So the perimeter is now 28 plus 18 plus 16. And if I add that all up, that's going to give me a total of 62. Now you want to watch your label. For perimeter, it's just going to be units. If they gave us a label inches, I could say 62 inches. Or if they said centimeters, I could say 62 centimeters. Okay, and lastly, on the back, we're going to take a look at some properties here. So it's telling us we have the midpoints of all the sides. They've been marked X, Y, and Z. Those are the midpoints. And it says we're going to mark the halves of each side divided by the midpoint with congruency marks. So for instance, I know RX and SX are congruent. I know SZ is congruent to TZ because midpoints will cut my segments into 2 equal parts. And lastly, I know RY and TY are also equal. So now it's going to ask us to draw the mid-segments. So if I connect the mid-segments, all 3 of them, and if I'm just thinking about this as a mid-segment, XY is a mid-segment of this triangle, so XY is going to be half the length of the third side. Well, half the length of the third side is going to be the same thing as saying the side length of SZ. So I could mark this with 2 congruent markings. Similarly, if I look at YZ, I see YZ is a mid-segment and should be half the length of RS. Well, RS, half the length, that's going to show me as XS, so I could mark that with 1. And if I follow that same process around, XZ is also a midsegment, and it would be half the length of RT. So I could see that would get 3 marks. So now they're saying, what conclusions can you draw about the 4 triangles? If I look at the 4 triangles, I can see that all of these triangles, all 4 triangles, are going to be congruent. And later on, we're going to see how we can prove it. But just to make note, I can say, well, all the sides are equal. So if all sides are equal, I can prove those triangles are all congruent. Which that means then the perimeters of all 4 of those triangles are equal. I can say the area of all 4 triangles are also equal. Okay, if we take this a step further, and maybe I just take a look at one little triangle, let's say for instance this bottom one. So we'll take a look at triangle XSZ. And if I were to compare triangle XSZ to the big triangle, triangle RST, there's a couple of things I can see here. As far as maybe area, the area of that little triangle is going to equal, I can say 1/4 the area of the big triangle. How do I know that? Well, I can take 4 triangles. I can see here's 1, here's 2, here's 3, and the shaded one, there's 4. They're all the same size, so it would take 4 of those little ones to equal 1 big one. Now, a little bit different, if we looked at the perimeter, think outer edges. So I could say the perimeter of triangle XSZ is going to equal 1/2 the perimeter of triangle RST. And we can notice that because if I take a look at the markings, I have XS is only going to be half the length. I can see XZ is half the length of the third side RT, and I can see XZ is only half the length of the third side ST. So all of these little sides are half the length of our big triangle, meaning the perimeter is only half the size. So those are some properties with midsegments. We will practice this more in class. I hope this helped.